Hello, hello. Ciao Matteo.
Ciao
Welcome back.
Luca! Hi folks! Hey, how are you doing?
Great. August is almost at its end. Summer is still there, luckily. And we are
Technically, but back to school.
back to school. But luckily, we are not age appropriate for back to school. But today, we are going to talk about something extremely cool, at least for me, about HTTP caching.
HTTP caching.
Yeah, I
Caching
still
in
remember.
general first, and then HTTP caching.
Yeah, I mean, the infamous caching, HTTP caching. I still remember when that was a hipster term. I was still in school,
Well, I
so
think I think it still is.
it will never die caching. Also because if modern systems they want to be performant, right? You need to cache, unless you don't want to have delays, network, all this like yucky stuff. But yeah, let's start like usual. Like, why do we need caching? What is I mean, we don't. Let's not point the finger to the usual suspect, microservices. They made it even more successful. Thanks,
We should.
microservice.
We should talk
Um,
about microservices and caching. But let's pin it.
let's pin it. Let's go through the Tao and pick one of the layers of microservice. Um, so usually, what you have an API that somehow makes call to other APIs or databases or any sort of system and is consumed by a client. That's 2025, but it was still probably in 1984 when we were both born.
Well, not
With the
true.
same
Also, there
system.
is an HTML. Come on, a browser.
Yeah, that's a client. That's somebody that calls this API,
Yeah,
right?
yeah.
And then then there is a browser, a mobile phone, anything that consumes this API.
Yeah.
Uh, and so, but what is the problem? Why do we need caching there?
Well,
I mean, it sounds like a elementary school question, but let's answer it. Cool.
well, the fundamental problem is that sorry, the green is gone. I didn't charge it, so that's a problem. Um,
And you
yeah,
see, caching also saves you
yeah.
from
Okay.
interruption.
So, okay, let's talk a little bit about why you need caching and why it's needed. And so the first bit, you need to. This is taught. This kind of stuff is taught at my university. So I don't know if you ever heard about this or not, but when you want to access the data, okay, there is a hierarchy, okay, of latency cost, okay, to accessing that data. The fastest you can get, if you need some data, it's in memory. If it's in memory, accessing it is fast, okay? Then, if it's not in memory, well, it might be on disk. You know, disks now are pretty fast, so accessing disks is actually not that slow, okay?
Yeah.
Some years back, it was actually kind of very slow. Could be very slow, okay? When I started doing, working with, well, not working, playing with computers, okay, I had tapes. Reading from tapes could be pretty slow if the data was on the other side. So you needed to go back or forward and so on and so forth.
Especially through a serial port.
Yep, pretty slow. Okay, so then if it's not on disk, okay, and even on disk you can have different kind of speed on the disks,
Yeah.
okay, and even on disk, if it's not on disk, then you need to go to the net. You can go to the network, okay, and it can be either a database or a network file system or even an API that you are calling to get the data. It's just a network call, okay. On the network call, okay, there is a lot of things that can be discussed, a lot of details like accessing file on disk, different type of data structure, different type of protocols. Things to talk a little bit about there is head of line blocking, which is a huge problem usually when doing this kind of systems. This is where, and the other one is the number of connections. So those two things together essentially are the major problems for scaling. Okay, so why we need caching? Okay, and then there are head of line blocking, number of connections. Okay, and then there is the fact that some APIs and systems can be slow. Okay, and some data might be complex even to retrieve. Imagine a SQL query that could easily reach hundreds of lines of code. Okay, like once I wrote this monster with some colleagues that was this high, printed in 10. We printed it and stuck on the wall because we couldn't really reason about it anymore on the screen. It was too big, so we print it on the wall to know what the heck was happening. Okay,
Don't do a union all, or else it's go.
but wait, it was 3 unions.
Which are not bad, but the issue, I mean, one day we could talk about like SQL performance.
But that query was incredibly fast for what it was doing. Okay, it was just very expensive overall because of. So whenever you're doing this kind of complex computation or complex data fetching, you usually want to avoid doing it a lot. Okay, you want to take, you spend some money, okay, some power, some CPU capacity to do that computation. Okay, you probably want to reuse, get the maximum value out of that, especially if your server is being accessed a lot. Okay, now there are systems where they all treat individual data for each user. Okay, so caching might make not much sense over there. Okay, might still be useful, but it's less important. Where caching shines is if I have a set of data that is used by multiple users. Okay.
And also if it has low variance, right? You want something that has low variance.
It's low variance. It's questionable. Okay. The key point when talking about caching, I always ask one specific question. That is, what is the window? Okay. What is your tolerance of the user in seeing stale data? So, if the user sees some data that is old, what is the tolerance you want to have? Okay. Can the user see data that is 1 minute old? Can the user see data that is 1 second old? Can the user can never see data that is less than half a second older? Okay, it really, like, if you're talking about the price of a stock, it's probably one.
Yeah, but think, for example, like an e-commerce, right? And content. Like content, I mean, it has low variance, maybe because you don't have like a million permutations of the text. But is let's say as high persistency, like it is not gonna change most likely in the next day or two, right? While the stock price, for example, or the stock quantity, can vary in any moment in time, right?
Yes, but even there, okay, there is a lot to discuss, okay, because it doesn't matter. Like, let's say if I'm selling, the e-commerce is selling, 100 pieces an hour of something, okay. If the stock, the amount of items in stock is 1,000, doesn't matter if it's 1,001 or 1,100. Okay.
No.
Not at all.
But it changes. Like
it
for
changes,
example,
but it does not change the experience for the end user. Okay, because it doesn't change the decision of the end user of buying it right now. Okay, it's
it depends. Like, for example, imagine in that case, right, in the e-commerce case, for example, where I would stop using cache or probably be a little bit more proactive is when there are last 10 pieces available.
Yes,
right?
exactly.
And then you want to show the data as live as possible.
Exactly, but that's only a minimum part of your of your products. Okay,
Yeah.
so you have a limited. So you essentially you want to be as real time as possible. Okay,
Yeah.
you want to be as real time as possible with real data. Okay,
Yeah.
with low stock items, and then longer for other items. Okay, so this means in practice that the amount of time we can keep some data cached depends on the actual content of that payload. Okay,
Yeah.
so
100%.
okay, so we have like so you need to think about the content, the content and the and its metadata, how long that content is, how long is fresh for. Okay, and its freshness metadata. Okay, so these 2 bits, usually a lot of people building APIs and things like that do not never consider this. Okay, they never think, oh, wait a second, how long can the user consume that data, how long is that data valid. Okay,
Yeah.
and note that, okay, to be clear, the moment a user receive any piece of data on a mobile phone or a browser, that data is stale by definition. Okay,
Yeah.
so somebody that says, "Oh, but my data in the in what I see in the browser can never be stale," okay, they are asking for something that is not possible.
Yeah.
Okay, to be
And if you think about, for example, at the old good times, you would implement caching in Varnish, HTTP caching, for example.
yes. Oh, you still do, by the way. You can still do that.
Yeah, yeah, yeah. But I don't think we heard the term varnish in the past like 5 to 10 years. I don't know. I personally haven't really heard so much, but um, there are different techniques, right, that you can do, that you can use. Because let's probably try to explain the HTTP caching model and how it can be implemented, like the
So
usual ETags and so on.
HTTP caching is a wonderful spec. Okay,
Let's clarify. It's a spec. It's not
it's a
a
spec.
random thing.
It's a
Right?
spec. Okay, and it has been iterated and worked on by a lot of very smart people. Okay, so it has already collected all, the shared experience of everybody. Okay,
Yeah.
so this spec is composed of 2 things: a set of headers and information, metadata, okay, to be attached. So a set of metadata in the form of headers and their semantics to be attached on server responses, okay, that will be used, okay, by a client to to keep that data valid on its own store, okay. Now, there is also the concept of an intermediate, so which can be a proxy, a reverse proxy, or a CDN, depends. Okay, there's an intermediate. If there is an intermediary, okay, a reverse proxy or a
Yeah.
CDN, there is also a special set of feature to classify its behavior. Specifically, there can be private caching metadata and public caching metadata that is getting stored in the shared in the intermediary to be sent to different users. Okay, you can even say, for example, okay, you can cache this data, Luca, but this data is only it's only for you. Okay, it's not for anybody else. So all of this is possible. Okay, and to be honest, a lot of every single time somebody tried to say like this is the major win, okay, of HTTP. So why would you use HTTP to build your application as a transport? Okay, is to leverage caching. The tools, the spec, all the interoperability of different systems, it's all done. Okay, so you don't need to figure it out. Okay, you don't need to build a new protocol on top. And I'm looking at you, GraphQL, by the way. Okay, and this is, by the way, one of the major downside of using GraphQL. You need to build caching on top or whatever. So what can Now, as we said, the cache in HTTP caching is on the client. Okay, it's not on the server. Okay, this means, okay, that if my app is calling your app, I need to build my cache, or I need to call you, okay, through a reverse proxy that add that cache for me. Okay, but there is the problem though that if I use, for example, something like Nginx, okay, that I need when I'm calling, when I'm passing to this proxy, I need to be sure that all the instances of the proxy have the same cache meta information, because otherwise I might, hit a replica that's not.
And how do you actually, because one I mean, you're right, it's a client-based caching.
Yeah.
But so how do I know if I need to make that request and retrieve it or not? Where is the secret?
So the secret comes with a few key headers. Okay, there's an header called cache control. Okay, that when you make when a response tells the cache what to do with it. Okay, so can it be cached for how long? Okay, and it can say different things. It can say, oh, revalidate. So every single time try and revalidate this data. Okay.
Yeah.
So ask it to me again, and then say not. This is very useful in case of big files, big transfers. So I can send a very quick request, and the answer can be, oh no, you already have it. Okay, great. So I can avoid transferring, I don't know, 10 megabytes or a gig or whatever. Okay, same file. Now, the other option is it's valid for, I don't know, a minute. Okay, fine, it's valid for a minute. Now, I can say in the cache control header to cache the thing, okay, but after it expires, okay, keep serving the stale data and then revalidate. So in this way, okay, you are essentially you're never hitting the top server. Okay?
Yeah.
This is very useful, for example, to deduplicate requests. Okay? So let's say if 10 requests arrives at the same time, okay, I can serve to them stale data and just only fetch to the origin once. Okay? Pretty good. There is also the point of to return from the cache if there is an error. So I can even say if there's an error, give it always return something to the end user, even if it's free. So I can use it even as a defense to protect my systems. Okay.
But for example, in this case, how would you use it? Because the defense kind of like mechanism sounds pretty interesting. But in what kind of use case would you use it?
Oh, the use case is very simple. Okay, let's say that it's very useful for handling spikes in traffic. Okay.
Okay.
So let's say that there is a massive spike in traffic. Okay, and my servers are hit. Cool. What happens now with my servers are hit? Well, they are stop responding because they are overloaded. They need to be scaling up. They can return a 503 error, okay? Try again in a bit of time, but because it handles the caching system is capable of handling that, it can just return the previous response.
Oh, so in combination with the too busy, you would basically use it.
Yeah.
That's actually pretty cool. But you mentioned about
and by the way, all of this is a huge spec, so there's a lot of cases that can be they're all part of this kind of system.
But I think what's interesting is that, like, being a client-side caching and being clearly controlled by the server, right, through errors.
Yeah.
I think actually that there's an interesting angle there, right? So because based on that line of thought, revalidation or invalidation would actually be way better than doing refetching, right? In this case.
Absolutely. Okay, so there is a few problems. Okay, one thing that the spec does not handle officially. Okay, the official RFC. Okay, which is let me get URL number because I'm horrible at numbers. So
we can put the link also in our comment.
RFC 9111. Okay. It's a new one, by the way. There has been a reissue of all the HTTP um, of all the HTTP RFCs. So this is part of that reissue. Okay. So let's say that what we were saying before that. This is the
The invalidation,
oh
revalidation
yes. So there is
versus
so
refetching.
it doesn't handle invalidation. So the caching, this kind of system does not handle invalidation. Okay. There is another spec. Okay. There is sorry. There's not another spec. There is an official system called cache tags. Okay, that is
Yeah.
essentially implemented by all CDNs. So typically it's called X cache tags because it's non-standard. Okay. So there is that. Okay.
Talk about HTTP standards one day.
Oh
Because
yeah.
everyone wonders why you call another X dash
Yes,
something.
but because it's non-standard. Okay. And it depends. So for some of them you can just drop X cache tags and so on and so forth. Anyway, so how it works essentially, when you specify that, you specify a common separated list of in an HTTP response. Okay, and then using some off the hook out of the line, okay,
Yeah.
API to your CDN or server or whatever, you can tell the CDN or your proxy or your systems, whatever, to start to purge that data, all the data that have that tag from the cache. Okay, this is very useful to do essentially cache invalidations. Okay,
Yeah.
across lists, across everything. So you can just say invalidate this, that all the URLs that have these cache tags. You don't need to list all your URLs. You just need to point the cache tags. Okay.
And in that, basically in that way, um, you are saving a massive amount of requests.
Now, so the point here is, so when it is a cache system, okay, we had there is a problem. Okay, what if you need to invalidate some cache? There is some bad cache, some bad data in the cache, and you need to invalidate it. The typical use case is
Linearly, right? So you mean a relation one-on-one between
yes,
data and
whatever,
consumer.
yes, yes. Now the problem is I have one piece of data that I want to invalidate. Now
Yeah.
the first thing you could do is to have a big red button that invalidates all of it.
Nuke.
Nuke. Okay, kaboom,
Cache gone.
cache gone. Okay, or you can selectively invalidate certain pieces.
But if the relation, if they are actually dependent from one to another, cache entry A, cache entry B depends on cache entry A. How
Yeah,
can
but
you actually traverse it?
you
Is
use
there
these cache tags.
but there's an automatic way, or you need to
Yes,
traverse it
yes.
yourself?
You just specify the cache tags and you call the Cloudflare.
Yeah, but how do I know that? For example, cache element. Imagine I have in cache element A, I have I'm caching the relationship user to account number.
Mm-hmm.
And in cache entry B, I have all the user information of which I have the account, right?
Yes.
And this user gets blacklisted, gets somehow, it needs to be disabled.
Yeah.
So I need to invalidate both.
Yeah, exactly. Yes.
But how do I know that? Is
They
there a
will
way
include the
actually
same cache tags
they will include the same cache tag?
in the response. There will be a response header called X cache tag or cache tag, whatever, that include the user account or the username or whatever you want to put in there.
And then
This,
I can selectively delete
yeah.
all entry that they respect that cache
Exactly.
tag query.
Exactly.
Okay. So I don't have to have the knowledge of traversing. I just need to have the knowledge of
Well,
tagging them
the
correctly.
server needs to tell this kind of smart index or tag to apply to those entries so that the CDN or cache, whatever,
Yeah.
knows to remove them.
So it's all about your tagging strategy more than anything else. Okay.
Yes, it's up to
Because
you.
I mean, if you think about caching, right? We saw many implementations. We also saw, well, another side of caching is clearly the component caching. So it is massively used clearly in front end.
Yeah.
But we saw so many caching systems that they were like completely homebrewed, that they were completely like custom made. And at the same time, we saw that none of them was really working. But what do you think are the main common mistakes that people are making in designing
Well,
such a cache
okay.
system?
The first one, okay, this is the first biggest mistake, okay,
Uh-huh.
is head of line blocking, as I told you about, okay?
Hmm.
Like, if you're not, like, you can't cache, in most system, you can't cache on disk, because if you start caching on disk, then you have a problem, okay, of
Yeah.
consistency of your cache data that you really don't want to have, okay? So that's the first problem, okay? But then the second problem is head of line blocking, because if you're going on a distributed network, you need to make sure that you can get your data from
Yeah.
your source, okay, without having all these pieces queued up, okay? So this means that you need to use whatever caching system you need to use needs to have a way to overcome head of line blocking. Otherwise, essentially, you know, how many sockets would you open to run in parallel? Okay.
Yeah, exactly.
So
And can you give
what is
a
head of line blocking? Head of line blocking is the problem where you do a request response. I send a message to Luca. I need to send two messages to Luca. I can send one message to Luca and then wait for the response and then send the next message back. This is how most RPC or most procedural protocol works. Okay. Or I can send two messages to Luca and Luca will send back both messages back to me. Okay. Of course, this second thing is way more complex to handle. Okay. And two
because
order
you
of
need to have
magnitude
out of order and so
it's super
on.
complex, okay? But it's what makes it powerful, okay? So you need to have this kind of system in place to handle this kind of stuff, okay? Otherwise, you're screwed, essentially. Big time screwed. So what it happens then? So you need to have this system now. In if you're using Redis, for example, you need to use a client, okay, a Redis client that supports something called auto pipelining, okay. So which is something that I created some time ago, okay, for a caching system, nevertheless, okay, because you needed to issue so many requests, okay, and you want to a lot of cache requests, you want to coalesce them into a single pipeline, Redis pipeline, and get all the response in a single op. Okay. Typically, getting cache data from Redis is a O1 read information. Okay.
Yeah.
So it's super cheap, super fast. So you can issue 10, 20, 100 of them, and then Redis will get them back at the same time in one single sweep of the one single sweep. If the packages are small, okay, this means that you can, in a single TCP packet can be so many cache entries, okay, which is super great, okay.
You mentioned Redis, and for a second I thought, it would be phenomenal one day to have in our chat
Salvatore. Oh yeah, we
Salvatore.
can. Let's work
Because I
on that.
think Redis is such kind of like, I think caching really took a massive leap with Redis.
Yeah.
A
So
massive.
anyway, there is caching with Redis, okay, but and that is the first mistake a lot of people do, okay. Like a few people do caching. So some people can say, oh, I'm doing some caching system on DynamoDB, for example,
Yeah.
okay, which can be used for that. The problem is the amount of IO throughput that you need to have to do proper volume HTTP caching
Yeah,
needs to be so high that you're going to spending a fortune on that system.
yeah.
Okay, um, and the same is true for other and for most of those other cloud databases where you pay by compute unit or something like that. Okay, um, because the cost for each request is higher than what you want to have. Also for S3 or something like that. Okay, it could
But
be
in
used.
that case, I think we are going to fall into the other kind of like side of the spectrum of caching, that is the more kind of like data caching, because HTTP caching fundamentally also solves the problem of distribution
Yes.
because it's client based.
Yes.
And the other problem with Redis or so on is that you need to have either central or somehow still distributed uh, close to the
Well,
to the
but the two systems are being client based. Okay,
Mhm.
it also means that I can always, and I'm saying always, okay, at an intermediate level that acts as a smart client that has caching for clients that don't have caching.
Yeah.
So,
And like for example, yeah,
well, yes, but it's not. Let's remove GraphQL from the equation, but I can like, it's a caching, it's a client-based caching. Okay, so
yeah.
Nginx, if my servers produce the right errors, my client we can just put an Nginx in front, and my client would always talk to Redis.
Oh,
To,
you
to
mean in that way? So it's some
Yeah,
sort of like cache inside the car,
yes, I
basically.
can put together a caching sidecar for my system and always have the caching. Now, the problem why this approach has not been done a lot, okay, it's because of cache consistency. Now, guaranteeing that all the replicas of this sidecar are consistent is a hard problem, okay?
Yeah.
It's a hard problem because typically Ready, for example, Nginx caches on disk, okay?
Correct.
And they try to say, no, but you're eventually consistent, okay? And they don't care, okay? But in a lot of cases, a lot of systems would care, okay? So something that we have start reasoned and built in some time is this integration with Node.js so that we can use Redis or Valkey as a cache store, okay?
Mhm.
For and have Node.js have its own HTTP caching system as a client. So when implementing a reverse proxy, you can actually have it, have this reverse proxy built in Node.js that store the caching data on a Redis or Valkey shared, okay, and do some transformations, do whatever you want to do there. Okay, it cannot just be a reverse proxy; it can be a full API layer calling other
Yeah.
services and stuff. But you can have the full caching data, and that system works by leveraging some key features of Redis for caching called tracking, which is pretty good, pretty cool. So I can have a in-memory piece and a remote piece, and the in-memory piece gets invalidated by the central piece. So I can have even a local copy of the data I need, which is pretty cool.
Yeah, it takes basically away that problem, that complexity of, like you were saying, distribution and coordination of the
Yes.
caching. And so, um, if you were to give a suggestion to everyone that wants to kind of like start the journey or improve their journey of HP caching,
Yeah.
what are the top three recommendations that you give to people? Like in terms of, imagine that I want to implement a caching to improve HP caching to improve scalability or to improve resiliency, or most of the time, caching is all about cost and latency.
First of all, okay, understand what is the how fresh your data needs to be. Okay,
Okay.
this is the first question. Okay, and I usually I had this question. I remember when I asked this question to a company I was consulting with, and they told me, "Oh, the manager told, oh, we need the data to be real time." And okay, can you please define real time? Oh, yes, of course. For me, real time is data that is, at maximum 3 5 minutes stale.
It's not really real time.
But okay, so this is the type of conversation that you need to have. Okay, then once you have that system, okay, when you have that knowledge in place, okay, you need to know what your system is being hit the most. Okay, so you need to create some sort of heat map of your
Yeah.
routes, okay, of your data that is very hot. Okay, so you have data that is very hot, and you know how long you want that data to be valid for. Okay, with these two information, you can start putting together your HTTP your HTTP caching headers, and then configure it on the server so that it gets rendered, it gets cached. Now you also
Mhm.
need to put some infrastructure in place to make that cache possible.
So you basically say, in any case, you need to understand what is the lifetime of your data, what is acceptable
Yes.
for your user experience
Yes.
to have as some sort of like data uh, live,
Yes.
um, and then basically go back and implement it on the server to
Yes.
enable all the cache
Yes.
tags and so on and so
Yes.
forth. And if um, in terms of like, because probably many people are interested about, I mean, it looks like the cost, it's a very obvious benefit of caching, right? Cost associated with kind of a better user experience. But if you look at, for example, e-commerce, let's
Yeah.
pick a random. What do you think is an easy way for people to understand the effective benefit of what they're doing, like the
Oh,
cost?
the major one is, if you structure your system correctly, is latency, which is, we know it's correlated directly to user purchase behaviors. So you
Yeah,
want your system to be fast.
yeah,
And the fact that it loads faster, typically because we can have that data close to the end user. Especially in e-commerce, it means having some smart cache strategy at the point of exit of your CDN, so that
yeah,
you can cache that data over there, so that a user in that area that accesses the data, well, even first will pay the price, but then the second user in that area will not. Okay, so that all the stuff that can be cached and put together over there can be done. So pretty great.
and
Um,
but if you basically have to tell some anybody, like, but you need to watch out for something. What would be the things people has to watch out for? Except probably for cache invalidation and coordination.
Cache private, leaking private information.
So you basically sanitizing the cache, or you mean be
Well,
more
you
conscious?
can't really. You need to be conscious of what you're like. A lot of people, a lot of companies, generic developers, thinks I cannot cache anything because all my response are user
Yeah,
specific.
yeah,
That's not true. Okay, you can see it in a lot of places, in a lot of websites. Okay, in a lot of websites, you load the home page of something. Okay, and by default there is a login button that stays there for like a couple of seconds. Okay, then it flips and your account appears. I don't know if you've never
yeah,
noticed this pattern,
yeah,
but
yeah,
this,
yeah. Every single time.
yes, that's HTTP caching at play for you,
Yeah,
because it's you're getting main content that is all HTTP cached and
yeah,
user generic, and is being cached. Okay,
yeah,
that piece on top is rendered live on your web page.
yeah,
Okay, after your main content has loaded, but the page has been cached, being served from cache, so it,
yeah,
it loads like that.
yeah. Because I want to lower the time to render to the user. I want to have the experience where there is no spinner, no loader. They want it
Exactly.
because, and I think that's actually a way better experience for everyone. Because one thing that I hate when I go on a website is to see the spinner. Something that I also dislike about mobile apps is that they all start with the concept of spinner. If you have to be logged in or so on to retrieve your data, but I think your data is always a consequence of something that already exists. Right? You can't. It's not that your profile differs from the business that
Yes.
you're accessing, like in e-commerce.
Yeah.
It's obvious, right? Um, So that kind of experience is, I think it's nailed in terms of like a good use of HTTP caching. And yeah, let me check the time.
I
Oh, we
think we
are
are
at
out,
our
Luca.
mark. Huh?
It fly. This conversation was fantastic. We
Yeah.
should do a session. I
Oh,
take two on caching, Luca, because it's
Jesus, this one was like maybe that we what we should actually park is uh, caching in correlation with component caching in the front end. That's another one. It touches
ooh.
more the world of Redis a little bit closer. But yeah, I think we did our banter for this week. We chatted
Yeah.
our usual time, and yeah, see you next week.
See you next
And
week.
next week is gonna be September
Ooh.
already.
Yep. Bye, guys.